This is Group 1,
Randall Elkind,
Emily Maharis.
Harrison Riggett.
Our team manufactured a 10-chamber plate heat exchanger.
Each chamber alternates between hot and cold water. For all cold water chambers, cold water enters through this inlet here and goes left. It follows this path here as shown and exits through this outlet here heading left. The hot water flow path is the same as the cold water flow path, however it's mirrored about this y-axis. So hot water enters through this inlet here and heads right, follows the mirrored flow path and exits right through this outlet up here.
The heat transfer occurs over the 9/16,000th inch thick aluminum sheets shown sandwiched between the red gaskets.
The front and back plates are 1/4 inch thick acrylic sheets. They're 6 inches by 12 inches in size and were laser cut. The aluminum sheets are 6 inches by 12 inches in size and were cut to size using a shear. The mounting holes were created using a drill press. The inlet and outlet tubes are 1/2 inch outer diameter, 3/8 inch inner diameter polycarbonate tubing. These were cut down on a bandsaw to about 3 inches long and superglued into the front acrylic plate. The gaskets for each chamber are 1/16 inch thick and are 5.75 inches by 11.75 inches. They were laser cut out of silicone rubber. Various aluminum components were used to provide an even clamping force for the heat exchanger. These components include 1 inch by 1 inch square tubing, 1 inch angle, and 5/8 inch wide U-channel. To manufacture these components, a bandsaw was used to cut them down to size. A drill press was used to drill the holes. The components mounted to the back side of the heat exchanger were tapped with the 1/4-20 thread.
This is our heat exchanger running under the desired conditions. No water leaked externally, however there was leakage between layers. Here you can see the front chamber filling up. We added additional chambers to our final heat exchanger for better heat transfer. We also added a flow channel to improve the flow. The flow channels were also designed to induce turbulence. Finally, aluminum bars were included in the final design to create even compressive forces without using an excessive amount of fasteners. This stopped any external leakage from occurring. While our first heat exchanger leaks both internally and externally, our final heat exchanger only leaks internally. Shown here are the temperature and volume flow rate values for our first and final heat exchanger.
If given a second chance, we should have designed a single clamping frame for the front and back plates instead of the various pieces of aluminum in order to create a more even clamping force distribution. Additionally, although we felt that we managed our time well, we recommend to future students who construct plate heat exchangers to plan ahead, expect to redesign, and avoid delaying progress to the last minute.